So I'm a third-year PhD student in the Department of Statistics. I work with Professor Mark Gerolami, and the topic of my research is probabilistic numerics, which are a way of constructing numerical methods which not only return an estimate of the solution of a problem, but also an estimate of how certain you are in the solution. So I think this is best illustrated with an example. And the example that I've chosen is one that I hope everybody can relate to, numerical weather prediction. So in numerical weather prediction, we take some very complicated equations, partial differential equations. This is a cartoon, not the real equations that you would actually solve, and some data, and we synthesize them together to produce a weather forecast. And the reason that these weather forecasts are always so inaccurate is because these equations are really, really difficult to solve. And in fact, solving them exactly is usually not possible, and that's what people use numerical methods for. So probabilistic numerics, the purpose of them is to not only produce a numerical method which approximates the solution to equations like this, but which also gives you an estimate of how right your solution is. And with that estimate of how right the solution is, we can hopefully maybe not make these forecasts more accurate, but at least know how well we can trust them, which helps us to make better decisions about the information, the forecast that we've obtained, which will lead us to make better inferences and make better decisions. So I published a few papers in this area over the course of my PhD. In fact, I shouldn't say published because these are all still in review, but hopefully they'll be published by the end of my PhD. And I just wanted to highlight the top one here, which has recently been awarded the prize for the best student paper by the American Statistical Association. Thank you very much. Just one clap.
Wait until it's accepted.
I see how it is. So that's the first part of my 5-minute talk. In the second part, I'm going to talk about my work with DataKind UK. This is something that I do in my spare time outside of my PhD. DataKind are a charity that provide pro bono data science to other charities, and the CEO, as has been mentioned, is here today. And one of the projects that I'm working on with DataKind is a project with the Wellcome Centre, which is a food bank in Huddersfield. They're quite a large food bank in Huddersfield. They provide nearly 10,000 food parcels every year, which is the equivalent of approximately 150,000 meals. And their stated mission is to provide short-term support to people who are experiencing times of crisis in their lives. For example, if they've lost their job, or they have some kind of drug dependency, and they just need some support to help them get back on their feet. Now, the issue that the Wellcome Centre came to DataKind with was that they found that there was a tendency for some of the people who were using their support to develop a dependency on it. They would not be able to resolve the underlying issues which were causing them to need food parcels, such as a drug addiction, and they would need to sort of keep going with the support for far longer than the Wellcome Centre would like to have to provide them with food parcels. And they have support workers who are trying to help people to address these underlying needs, which make them need food parcels, such as direct them to drug-dependent support charities. But sometimes it's difficult for the support workers to identify the people who need that support fast enough for them to provide it. So that's where we come in. This is how the Wellcome Centre's workflow works. So a client will come in requesting a food parcel, they'll call into a call centre, and the call centre staff will currently try to identify those people who actually need extra support to refer them to a support worker. But at the same time, they also enter some information into a very comprehensive database of information about their clients that they've been maintaining for many years. So where we come in is in this portion over here, where I've got two more cartoons of the kind of analysis that we're doing. So we're producing some machine learning algorithms combined with some statistical methods to produce a predictive model, which will use the information which is stored in the database together with the information that's collected about the client when they call in, to produce a prediction as to whether this is the kind of person that might need that extra support from the support worker. And if the algorithms return, yes, this person should be referred to a support worker, then this will be flagged up to the call center staff so that they can alert the support worker in advance to come and see this person, and that will hopefully reduce the number of food parcels that the Wellcome Centre needs to distribute to these people by sort of addressing their dependency much earlier. And that will mean that they can distribute more food parcels to more people in need, and their money will go further and they'll be able to help more people. So this is where we're hoping that this StatForge project will help out, because there's some really quite complex mathematics and statistics and data science going on in this section here, and I feel that academics can make a really serious contribution in that sector, which maybe we're not making the contribution that we could be at the moment. So hopefully with this project, more academics will become involved and we'll be able to help more people. Thank you.